Hello, this is Mrs. Pye again. We are doing our 5th video on composite functions. This time you're not going to see my face, but you will see me drawing stuff on the board as I work through the problems. The first thing we want to do is just talk about composite functions and the annotations that you will see with composite functions. You can have, whoops, that's way too big. Sorry about that. All right, you can have a composite function written like this or like this. This symbol right here is just an open circle. It is not a times symbol. Please don't confuse the two. Every time you see it, you will see a very round open circle. You're not going to see like an asterisk. Sometimes you'll see an asterisk for a time symbol. You won't see anything like that. It'll be F, open circle that represents the word of, G, and that's how you would read this. You would say F of G. In other words, you're going to take the formula for G and plug it into the formula for X. Okay? In this video, we'll go over composite functions and the domains of composite functions. I know originally I put the range up here too. We're not going to worry about the range, just the domain. Okay. So we're going to look at, we have the formula f of x equals x plus 1 over x, and g of x is the fraction x plus 1 divided by x plus 2. We are going to find f of g of x. In other words, our g of x formula will go into the f of x formula, and then we'll find g of f of x. This is just another way to write out composite functions. So in this case, the formula f of x will go into the g of x formula. And then finally, we'll find g of f of 1. Okay? So let's go ahead and get started. The first one, f of g of x. To set up the formula, you're going to take the g of x formula and plug it in for every x in the f of x formula. When you do that, it'll look like this. Okay? So here's our g of x formula that went right here for this x, and here's the g of x formula that was filled in for this x. Okay? Once you do that, you need to simplify. When you have a fraction right here, a fraction inside a fraction, and you have a 1 on top, you can take the reciprocal or reverse the numerator and denominator. So right here, all I did is I took this fraction and flipped it right here. Okay, we can continue to simplify this by getting common denominators. Anytime you want to add or subtract a fraction, you have to get common denominators. Okay? When you get a common denominator, I want to have x plus 2 and x plus 1 in the common denominator as the denominator. So my first fraction here is going to get multiplied by x plus 1 over x plus 1. This is equal to 1. So x plus 1 divided by x plus 1 equals 1. And so really all I'm doing is multiplying it by 1, but I'm changing the denominators. And then for our second fraction, we want the denominator multiplied by x plus 2. So we have x plus 2 divided by x plus 2. All right? So once we get our common denominators, we get this solution. Notice that I'm leaving my denominator separated like this. I'm not foiling. I left that separated. Up here, I went ahead and foiled the x plus 1 times x plus 1, and that's where I got this x plus 2, or x squared plus 2x plus 1. And then over here, I'm multiplying my x plus 2 times x plus 2, and I get this part of my fraction. Okay? At this point, I can combine all like terms, and I get my final answer, and this part I cannot simplify anymore. Okay, this is as simple as it gets. I get 2x squared plus 6x plus 5, and then in the denominator I have x plus 2 times x plus 1. Okay. Now, when you're looking for the domain of your composite functions, there's two things you have to look at. Number one, if you have a fraction, anything that will make the denominator equal to 0 will be excluded from the domain. So in other words, if x was negative 2, if I have negative 2 plus 2, I get 0. 0 times anything is 0, and I end up having a 0 in the denominator, and that becomes an undefined term, or that would be where my asymptote is. If x was negative 1, and I have negative 1 plus 1, I also get 0. So right there, two of my restrictions on the domain are x cannot equal negative 2 or negative 1, because both of those values will cause you to have a 0 in the denominator. Okay. The other place you need to look at is in the original equation, okay, up at the very top. Now, the formula that I put inside of f of x was g of x, so anything that will make my g of x undefined will also be included in the domain for this problem. So if we look at this denominator, if x was equal to negative 2, then I would have negative 2 plus 2, which would give me 0. So again, we could not have negative 2. Now notice this time I already had my negative 2 down here, but you will find that sometimes you'll have restrictions based on the composite function here, and you'll have other restrictions on the original formulas. You have to include all of the restrictions on the domain, whether it's the composite function here, the final composite function, or the original formula that was put inside another formula. All right, so to write this domain out, you would have parentheses, negative infinity to negative 2, the little conjunction u, and then negative 2 to negative 1, another conjunction u, and negative 1 to positive infinity. And that would be the domain for this composite function. Let's go ahead and look at the next one. This time, the annotation for the composite function is written a little bit different. This is the same thing. This reads g of f of x. In other words, f of x is getting put inside g of x. So now when we do that, all my x's in g of x change to x plus 1 over x, and we get this fraction. Okay? So this x here became x plus 1 over x, and this x here also became x plus 1 over x. Are we good so far? Now, we want to simplify that further. We want to combine everything. I've got a lot of numbers there. I want to combine everything. In order to do that, I have to have a common denominator because of this fraction and this fraction. So I'm going to, everything that does not have a x as a denominator, I'm going to multiply by x over x. This one's a long one. Okay, let me move this up. Oop, too far. Alright, well, that'll have to be good. Alright, so this x is multiplied by x over x, this 1 is multiplied by x over x, the 2 and this x is multiplied by x over x. Okay, notice I don't have to multiply these fractions because they already have x in the denominator. Okay, once I multiply everything, I'm going to have this situation here. Okay. Now they all have common denominators. I can combine like terms, and I have this situation. Once I combine like terms, yeah, that's it. Okay, so I'm combining like terms here, and notice again I have a fraction and a fraction. So I can take my denominator and multiply it by the reciprocal of the denominator. And when I do that, I get this. The terms that would make this equal, the denominator equal to 0, let's see. Right now I have x of cannot equal 0. I'm still trying to figure out that one. Oh, you know what? I got it from the original equation. All right. So from my composite function, the only restriction I have is x cannot equal -1. Because if we had -1, this would become 1 plus -2 plus 1, which would give me a 0 in the denominator. So according to the composite function, x cannot equal -1. If I come back to my original f of x, if I come back here to the original f of x, if I have a 0 for x, then I have an undefined term there. So my domain will be x cannot equal 0 or 1 or -1, and you would write it out again, starting with -infinity, stopping at -1, and then -1 to 0, and then from 0 to positive infinity. There's your domain for that problem. And then finally, g of f of 1. So what I'm going to do with this one is I will plug in 1 for x right here. And when I do that, I have 1 plus 1 over 1, which equals 2. Okay? And then this is the number that's going to be plugged in for x here and here. And I will simplify everything out that I can. And I get my final answer of 3 over 4. Super easy. It's a lot easier than it sounds, or than it first looks. One thing I do want to point out before we end this video is notice this is the solution of g of f of x. Okay. If you compare that to your solution of f of g of x, okay, notice they are not the same thing. You will not always get the same answers when you do your composite functions, when you're putting one formula inside the other one, and vice versa. All right, so we'll talk about more composite functions tomorrow when you come to class. Have a good day.